Hey YouTube, I'm Kishan and in this video we are going to crack the Netflix architecture design. So this video is quite unique to my channel. If you like it, make sure to hit the like button and subscribe to the channel. And I want you to stay tuned till the end of the video because I've got some exciting news for you. There's a challenge waiting for you at the end of the video and I'm going to pick top 5 winners for this challenge, and the winners will get a free 1 hour of session for interview preparation, development guide. Apart from that, you will be also getting the source codes for my upcoming videos like Instagram clone, Amazon clone, ChatGPT clone, Twitter clone for free. So make sure to watch the video till the end and don't forget to like this video and subscribe to my channel. So now without wasting any time, let's get started. So we are going to name this file as Netflix architecture design. And now let's discuss the functional requirements and the non-functional requirements that are going to be needed for this architecture. So the functional requirements are: the user should be able to upload the content, the user can search the content, the user can view the content, and we also need some analytics platform integrated with this system. Now, the non-functional requirements would be: the system should be scalable, it should be of low latency, and also it should be cost effective, it should be highly secure, and it should have an amazing availability. So those are the requirements that we have to meet. Now let's head over to Canvas, and now in here let's start our architecture design. So first what I'm going to do is I'm going to design a system for uploading the video. So for that I'm going to click on this plus icon and going to select a user from here. This is a user. Let's enlarge this, and I'm going to use an S3 bucket, this thing. So S3 stands for Amazon Simple Storage Service. It's a cloud-based storage provided by Amazon. Now, this is the Netflix admin. So what I'm going to do is I'm going to denote this with red color because this is the Netflix admin, and I'm going to use line, and the lines should be of elbow type, and I want both the arrows, and this is a dotted line. Going to select the text and write here as Netflix admin. Okay, so this is the Netflix admin, and now Netflix admin uploads the videos to the S3 bucket. So I'm going to select the line again and connect this with this, and this is going to be arrow, having the arrows both side, and this is of white color. Okay, so now the user uploads Okay, so now Netflix admin uploads the videos to the S3 bucket. Also with this, the videos would have title, tags, and description. So this is the metadata for the videos. So with this, the videos would be searched with the titles, the tags, and the description. And I'm going to use a line, connect this with this. So the Netflix admin uploads the video and inserts this data, and this would be stored in a database. So for the database, we are going to use the NoSQL database, and the best choice that we have for this kind of data is the Elasticsearch database or the Amazon's OpenSearch database. So I'm going to search for OpenSearch here. I have it right here. Connect this with this and right, stores. So the title, tags, and description would be stored in the database, which is Elasticsearch or the OpenSearch. So I'll name this as Elasticsearch or OpenSearch. So this is a NoSQL type of database, and we want this system to be scalable. If we head over to here and we can see that we want this system to be scalable. And if we have used any kind of SQL database like MySQL, and consider a scenario when you upload a new web series and you have many users simultaneously watching at a single time, then you need to increase your servers for scalability, because a single server cannot handle that many of requests. So at that time, the scalability would not be possible with the SQL databases. So for that reason, we are going to use the NoSQL database, and for this we have the best option, which is Elasticsearch and OpenSearch. Now after this, data is uploaded to the database and the video is uploaded to this S3 bucket. We need to process this video. So why would we need to process this video? Because this video could be of any format, 4K, 2K, 8K, 480 pixels, and we need to convert this video to multiple different formats according to users' needs. Like if you are watching the movie in a mobile device, then the resolution would be 480 pixels. If you are using on a tablet, then the resolution would be 720 pixels. If you are using on a television, that would be 1080 pixels or 4K resolution. So for that, we need to process our video, and for that we are also going to use the AWS services. So now what I'm going to do is I'm going to write 720 pixels. Okay, so these are the resolution in which we want our video. Now for the conversion of this, we are going to use the AWS Elemental Media Convert, which helps us to convert the video in different resolutions, and we can store the videos in chunks. I'll explain why we need the video in chunks in few minutes. Now let's have the AWS Elemental Media Convert. This one right here, we need this. Going to enlarge this, keep it right here, and going to have another rectangle here. And I'm going to select an arrow and have a line here in which we'll write AWS Elemental Media Convert for converting to different resolution and storing them in chunks. Make sure that this line is dotted. We'll have this of red color. And while this is being converted, we also need to check that if there's any adult content uploaded to this. And for that, what we are going to do is we are going to use the AWS recognition. Going to select this, have it right here, increase the size. So what AWS Amazon Recognition is, it's a AI/ML model that runs over your images and video and helps you recognize that if there is any adult content in the images or the video that is being uploaded. You can also use your custom models here if you know AI/ML. In this scenario, we are going to use the Amazon Recognition, and we are going to have another layer, AWS recognition for adult content. So this will help us recognize that if this is an adult content, and we'll have the color as, let's use blue here. Now all of this process should run simultaneously after the video is uploaded, and while the video is converting, we also need to check for the adult content. So for this, we are going to use the AWS step function. So step function, and we are going to have this here. So AWS step function is used for parallel processing. AWS step function for parallel processing, and we'll also write parallel processing here. And now we are going to connect this upload with this. And this is not a dotted line. We need the white line. Okay, so now we have a processed video, and now we have to store it somewhere. So what we are going to use again is the S3 bucket. S3 buckets are very cheap compared to our local hard disks. I'm going to copy this and paste it and have it here. So after this process is completed, I want to upload the video to our S3 bucket, and after this video is uploaded to this bucket, users can access it via a CDN. So here we are going to use a Netflix CDN. So for that, let's have a CDN, have this cloud right here. We are going to name this as the Netflix CDN, which is Open Connect. A CDN is a content delivery network of interconnected servers that speed up your web page loading for data heavy applications. It's a distributed cloud network. So this S3 connects with this right here, this cloud right here. Okay, so now I'm gonna need two more S3 buckets. I'll explain that in a minute. I'm going to copy paste those. So this one is going to be here and this one is going to be here. And let's name this bucket as frequent access bucket, and let's name this bucket as infrequent access bucket IFA, and let's name this one right here as glacier or cold storage. And now let's connect these buckets. Now this bucket right here is the frequent access bucket. The frequently accessed movies or web series would be stored inside of this bucket, and this bucket would have a high bandwidth, high storage capacity. And now Amazon S3 buckets provide some tiers, the premium tier, the standard tier, and according to the tier the pricing is set. And for example, this one right here is kind of a premium tier. So this is frequent access. This will store the frequently accessed movies which are in high demand. So it will have a low latency time. Whenever a user searches, it would be from this frequent access. This will have a high speed bandwidth, and after this the movies that are not searched frequently would be stored in this infrequent access bucket. This would be kind of a second tier package which would have a low bandwidth than this bucket right here, so it saves some money. And this one right here is the cold storage. We can also name this as glacier. So this one will have the movies that are only searched few number of times in a year, so it will also save up the cost. Now whenever we need any movie from here, CDN will check if we have the movie inside of this. If we don't have it right here, then we will request it from infrequent access, and if we also don't have it here, it will then search it in the cold storage, and then it will transfer it to the infrequent access and then to the CDN. And now when any movie is searched and returned from this infrequent access or any of the storage, this would cache the movie there. So anytime in future if someone again search for this movie, then it will not connect to this frequent access. If this movie is cached in the CDN, then it will just return it from here. So the time and the bandwidth is saved here. Again, there would be numerous amount of CDNs that would be available. So some would be in India, some would be in Canada, some would be in US, and according to your location, ISP will connect to your nearest CDN and it will check if the movie is cached there, and if it is cached there, then it will return the movie from there, or else it will connect to the frequent access and return the movie to the CDN and cache it and return it to the user. So with this, we have completed this upload content functional requirement, and this is scalable with low latency, and which is also cost effective because of the S3 buckets, and this is also highly available because of the load balancers. And for making this system secure, we are going to use it via HTTPS and with Cognito access token, so it makes it secure. Now we also need this analytics platform, so our upload content is complete. Now let's have the analytics platform also. Let's head over to Canvas. I'm going to move it here, and now we'll have Kibana from here. Also, we will have Logstash. Let's have the arrow here. Now, this is Kibana and this is Logstash. So, this Kibana would be used for visualizing stored data, and the Logstash would be used for logs management, and this right here will act as a database and store the data. For storing data, DB, and this is the ELK stack for analytics. Okay, So what ELK Stack is, it's a combination of Elasticsearch, Kibana and Logstash. So Elasticsearch will act as a database. Kibana is a highly scalable platform for visualizing data. It has multiple options for visualizations and we can have analytics from this platform. And now we also need Logstash for logs management. So for any logs in our system, we need Logstash and we'll manage it through the Logstash. So this ELK stack will be used for analytics. So our analytics platform is also complete. I'll just zoom out and I'll again explain you the process. So this Netflix admin uploads the movie and also uploads the metadata, the title, the tags, the description, and it will be stored in our Elasticsearch or the OpenSearch database. After this, the uploaded movie would be processed in small chunks and in different formats and resolutions. And for that, we are going to use the AWS Elemental Media Convert. Now, we will also be using AWS recognition for recognizing the adult content. We don't want adult content in our system. And all of this should be processed in parallel. And for the parallel processing, we are going to use the AWS step functions. Now, after the movie is processed, and then it will be stored inside the frequent access S3 bucket. And after the 30 days or 60 days period, if the movie is not watched frequently, then it will be moved to the infrequent access bucket. And after 30 to 60 days, if the movie has a low watch rate, then it will be again moved to the glacier. So the cost for this frequent access would be very high. The cost for this infrequent access would be lesser than this, and the whole storage cost would be very low. And after that, whenever the user searches any movie through the CDN, it will check if the movie is cached in the CDN. If it is not, then it will access the frequent access and get the movie and return it to the CDN, and it will cache it and it will return chunks to the user. Now we also have this ELK stack for analytics. It comprises of Elasticsearch, Kibana and Logstash. Elasticsearch is the database, Kibana is used for visualizing the stored data, and Logstash is used for logs management. So now this is complete. Now what we want to do is we want to design the system for searching the content and viewing the content. So let's do that. And for that, what I'm going to do is, so I'm going to search for laptop here. We'll have a phone. The user can also watch from a television, and user can also watch from a gaming device like an Xbox or PlayStation. We'll have it here. Let's give all of this a color of red. Now the end user will contact Netflix. So let's search for Netflix. Let's write Netflix here. Increase the text as X large. Have it here. And I think we need to zoom in. Yeah, we need to zoom in. Let's decrease the size of these things. So these are end users. So now end users will try to connect to netflix.com, and netflix.com will contact its CDN OpenConnect, and we are going to connect this, and this will in turn connect to a S3 bucket which will get the static website. Let's change this to white. So this CDN will connect to this S3 bucket to get the static website for the user, and the static website would be written in React. So let's have a React icon here, and let's connect this dotted lines. We'll change the color to this. So our end users will connect to netflix.com, and it will connect to the CDN. Then the CDN will connect to the S3 bucket, and this S3 bucket would just store our React application and return it to the end user. Let's change the color of this. And now the end user will search for a movie, and this CDN right here will check if the movie is cached inside the CDN. If the movie is not cached inside it, what it will do is it will connect to a API gateway. So these would be Netflix's microservices. So the CDN will call the API gateway, which in turn will trigger some Lambda functions. So let's connect this with this, and this Lambda function will get the movie IDs and the metadata from our database. So it would be stored inside the Elasticsearch. So I'm going to search for database. So this Lambda function will pass in the search query and this database right here. Let's denote this as database. And this will return the movie details to this Lambda function, and this would return this to this CDN, and this CDN will then call to another S3 bucket. So this S3 bucket will store the movie in chunks, and it would be in HLS format, and this will return the movie to the CDN, and the CDN will return the movie to the end users. And the CDN also caches the movie. So if any of the user in that region searches for the movie again, then it would already have the movie inside of this, and it will save the time and resources to access the S3 bucket, the API gateways, the Lambda functions, and the database costs. Okay, so that's it for the Netflix architecture. I hope you have enjoyed this video, and now I've got a challenge for you. I want you to add a recommendation feature based on the user search. So you have to store the user search preferences and use some AI/ML models to run on user's search history and show him the relevant content. You can use the AWS services for this and place it anywhere here. And then I want you to write a blog about this with the screenshot inside of it of what you did, and send me the link of the article inside my Discord channel. You can find the Discord link in the description of the video. Also, I have used the eraser tool for the diagram. You can use this tool to create the diagrams, and I will select top 5 winners, and the perks for winning would be a 1-hour one-to-one guidance session with me and free access to the source code of my upcoming clones. I hope you like this content, and if you want more videos like this, like WhatsApp architecture design, Twitter architecture design, Instagram architecture design, Amazon architecture design, just let me know in the comment section below. This is me, Kishan Sheth, signing out. Thank you.